is the function given below continuous slash differentiable at x equals 3, and they've defined it piecewise, and we have some choices. Continuous, not differentiable, differentiable, not continuous, both continuous and differentiable, neither continuous nor differentiable. Now, one of these we can knock out right from the get-go. You cannot, in order to be differentiable, you need to be continuous there. So you cannot have differentiable but not continuous. So let's just rule that one out. And now let's think about continuity. So let's first think about continuity. And frankly, if it isn't continuous, then it's not going to be differentiable. So let's think about it a little bit. So in order to be continuous, f of, let me do this in a darker color, f of 3 needs to be equal to the limit of f of x as x approaches 3. Now, what is f of 3? Well, let's see. We fall into this category, this case right over here, because x is equal to 3. So 6 times 3 is 18 minus 9 is 9. So this is 9. So the limit of f of x as x approaches 3 needs to be equal to 9. So let's first think about the limit as we approach from the left-hand side. The limit as x approaches 3 from the left-hand side of f of x. Well, when x is less than 3, we fall into this case. So f of x is just going to be equal to x squared. And so this is defined and continuous for all real numbers. So we can just substitute the 3 in there. So this is going to be equal to 9. Now, what's the limit of, as we approach 3 from the right-hand side of f of x? Well, as we approach from the right, this one right over here is f of x is equal to 6x minus 9. So we just write 6x minus 9. And once again, 6x minus 9 is defined and continuous for all real numbers. So we could just pop a 3 in there, and you get 18 minus 9. Well, this is also equal to 9. So the right and left and right hand limits both equal 9, which is equal to the value of the function there. So it is definitely continuous. So we can rule out this choice right over there. And now let's think about differentiability. So in order to be differentiable, I'll just differentiable. In order to be differentiable, the limit as x approaches 3 of f of x minus f of 3 over x minus 3 needs to exist. So let's see if we can evaluate this. So first of all, we know what f of 3 is. F of 3, we've already evaluated this. This is going to be 9. And let's see if we can evaluate this limit, or let's see what the limit is as we approach from the left-hand side and the right-hand side. And if they're approaching the same thing, then we know that then that same thing that they're approaching is the limit. So let's first think about the limit as x approaches 3 from the left-hand side. So it's over x minus 3, and we have f of x minus 9. But as we approach from the left-hand side, this is f of x. As x is less than 3, f of x is equal to x squared. So this would be, instead of f of x minus 9, I'll write x squared minus 9. And x squared minus 9, this is a difference of squares. So this is x plus 3 times x minus 3. X plus 3 times x minus 3. And so these would cancel out. We can say that this equivalent to x plus 3, as long as x does not equal 3. And that's okay because we're approaching from the left. And as we approach from the left, well, x plus 3 is defined for all real numbers. It's continuous for all real numbers. So we can just substitute the 3 in there. So we would get a 6. So now let's try to evaluate the limit as we approach from the right-hand side. So once again, it's f of x, but as we approach from the right-hand side, f of x is 6x minus 9. That's our f of x. And then we have minus f of 3, which is 9. So it's 6x minus 18. 6x minus 18. Well, that's the same thing as 6 times x minus 3. And as we approach from the right, well, that's just going to be equal to 6. So it looks like our derivative exists there, and it is equal, the limit as x approaches 3 of all of this business is equal to 6, because the limit as we approach from the left and the right is also equal to 6. So this looks like we are both continuous and differentiable.